Oh, are you still there? Okay, sorry, I pressed something and you almost disappeared. Okay, perfect. So we are told that this is a function of p. So when we look at d of p, that means that this is the dependent variable, and this is the independent variable, and you can see it's p. Now, when I replace p in the denominator of this fraction, I get d this time of t, which is 80,000 divided by 1.6 t plus 9. So that's part A. That's all we're asked to do. So once I replace p as a function of t, now this automatically becomes a function of t because p is gone. There is no more p here. And in the second part, in part B, we're asked find. So in order to determine d prime of 100, I have to find d prime of t first. So I have to differentiate this. So by this time in section 1.7, I know the chain rule. And since the numerator is a constant, always make your life as easy as possible. 1.6t plus 9 raised to negative 1. This is what I prefer to differentiate. You can say, I don't want this. I'm going to differentiate that. Fine. It's not a problem. But you have to keep in mind that when we differentiate the top, it gets 0. So be careful with that. Yes, you can differentiate this or differentiate that. You'll get the same answer. So I bring down the negative power. So I get negative 80,000 multiplied by 1.6t plus 9, and I have to subtract 1 from the power. And then I have to multiply by the inner function prime, which is 1.6. So now when I plug in, you can leave it as is or just multiply. So this is minus in front, and this goes to the denominator. And let's see what I get. 8 and 4 and 1, 2, and 3 zeros, because 1 will go away. Okay, so now for d prime of 100, I get negative 128,000 multiplied by 100 times 1.6. It's 160 plus 9, 169 squared. I don't know what that is. So 128,000 divided by 169 squared. So I got approximately 4.48. If I leave it, negative. So I'm going to write it here. Negative 4.48, which means at that instant it's decreasing, the rate of change is decreasing. But now I have to find the measurement unit. If I leave it like this, so please, I'm begging you, if it's an abstract problem, you don't have to worry about the measurement unit. But if we have like in this particular situation, we have D was demand function. So the rate of change of demand per day. So this is quantity function of time. So units, since this is measured in days, units per day. So it's decreasing at that instant.
When we answer a question like that,
yes.
So in that question, I rounded to the third decimal point.
That's fine. So it depends on what it says. It will be specified for you.
Okay, thank you. And
yeah.
If I was wondering if we could go over a problem that was on page 172.
So before you tell me which problem, any questions on this? Any questions on the previous one? Okay, I'm ready.
So it's problem 24. It wasn't in the homework, but it was in my lab math homework.
So you said 24?
Yeah.
Okay, very good. So 24. So this is the f of x. Am I correct? Is the cube root of x squared minus 1 squared?
Yeah.
Okay. So if you remember from last time, I said this is not a good setup. This is the best setup. So we know that every radical is basically a quantity and the exponent is a fraction, 2 over 3. So for everyone, as a refresher, the nth root of x to the mth mn is x to power m over n. The index is always the denominator. So every time I see a radical, I can change it into what it is equal to in an expression which has a fractional exponent, a ratio as an exponent. And from here, this becomes somewhat trivial, but not without this. So then when I determine f prime of x, I bring down the power. I subtract 1 from the power. Remember, 2/3 minus 1 is negative 1/3. So negative 1/3 times the inner function prime. Can anyone give me the inner function prime?
2x.
Excellent. So now I can write 2 times 2x at the top, 4x, divided by 3 is in the denominator. This has a negative exponent. It goes to the denominator as the cube root of x squared minus 1. But remember, as I said from the very beginning, 2 key words you should always have these in the back of your mind. Simplify and factor. These are key words at all times. Do I want to work with this? No, I want to work with that. So I simplified it in some way so that it's easier for me to differentiate.
So the problem actually was that after you did it the first time, you had to do it a second time too.
Okay, so now we want the second derivative.
Yeah.
Okay.
I was struggling with that.
Oh, I'm sorry. I didn't pay attention. Thank you so much for reminding me of that. Perfect. Do I want to differentiate this? Of course not. What I'm going to do, I'm going to arrange it appropriately. 2 over 3 times 2, and leave the constant alone. And then I have an x times this. Yes, this is not an easy situation. I have to agree. So this is just the first derivative for now. Now I want to find the second derivative. I will leave the constant outside. The constant is a factor. It's a factor, so that's why it can wait patiently. It will wait patiently. It's a product now. This is the first function. This is the second function. I differentiate the first, and I get 1 times the second. Plus, that's what the product rule says. Keep the first one untouched. Times, differentiate this. Bring down negative 1/3. Multiply this by negative 1/3 and minus 1, which is negative 4/3. I rushed to present this bracket. I need more room. So this is x squared minus 1. I'm going to replace it. I'm going to delete it. To negative 4/3 times the inner function prime. And then the bracket. Not a nice function at all. I completely agree with that. Okay. So now let's try to maneuver it a little bit. So I still have the 4/3 in front. This does not change for now. Is x squared minus 1 to negative 1/3. Let's see what happens here. I have a 2x times an x with minus 1/3. So it's going to be negative 2x squared over 3. Negative 1/3 times 2 is negative 2/3, and x times x is x squared, and then this is x squared minus 1 to negative 4/3. There is a way of simplifying this by factoring. I will factor out x squared minus 1y because it's present in this term and also in this term. But now we have to analyze which power do I pull out. And the answer is always the smallest of the two. So let me just come back here for a second. So when I want to factor out from x to the fourth plus 3x squared, what do I factor out? What is common to these two? Very good. The smallest of these two. And then what do I have left in parentheses? From 4, I subtract 2. So I have x squared. From 2, I subtract 2. They're gone. So plus 3. Is this true? Yes, it is. Because x squared times x squared is this, and x squared times 3 is this. So in the same way, here we will factor out the smallest of these two numbers. Exactly how, yes, of course, they're negative. Yes, of course, they're fractions, so it's more difficult. But the concept is the same. I still have to factor out the smallest of the two. Which is the smallest of the two? Negative 1/3 or negative 4/3? I know it's silly to even ask.
Negative 4/3.
Thank you very much. Good. So now let's see what happens. From negative 1/3, I subtract negative 4/3. But this is 4 minus 1, which is 3. 3 over 3 is 1. So I have an x squared minus 1. This happens to be completely out. So minus 2, x squared over 3. I will find the least common denominator, which is for this piece.
3.
Very good. So then this needs a 3 and this needs a 3. So 3x squared minus 3 minus 2x squared. So this will be x squared minus 3 over 3. X squared minus 3 over 3. Do not try to simplify. Remember, we only simplify factors. So all this piece is this. So finally, I'm continuing here. So 4/3. This can be brought to the denominator. So, and then the denominator has 3 times 3. So 9. This is x squared minus 1 to 4 divided by 3. And numerator has 4. Quantity x squared minus 3. Not nice. A lot of work. Very easy to make a mistake on such a problem. Not a nice function to differentiate the second time. The first time was okay, but differentiating the second time was not nice at all. A lot of steps. Factoring, simplifying. Say it again.
Thank you for going over that.
Thank you. Is this okay?
Yeah, thank you. I was just having trouble with, like, towards the end, I kept messing up.
Okay, no worries. Yes, we do this in college algebra, but and also with fractional exponents. Good. I'm ready.